This is a Chapter 8 pre-AP test, Part 2 review. All right, so the first question says to find the volume of the pyramid. So if we're looking at our volume formulas, for a pyramid, it would be 1/3 the area of the base times the height. So the area of the base of this pyramid, this is a square pyramid, so the base is a square. So we want to start by finding that area. So square would be base times height, so we would multiply 8 times 8, and that would give us 64. All right, so then to find the volume, we want to do 1/3 of 64 times the height of the pyramid, and the pyramid's height is 6. All right, so I can do 64 times 6. That gives me 24. 6 times 6 is 36, plus 2 is 38. And then I need to divide that by 3. So 3 will go into 384, into 3 once, into 8 twice, and then I bring down the 4, so 3 will go into 24 8 times. So my volume will be 128, and this is measured in cubic inches. All right, for number 2, it says a rectangular box has a volume of 392 cubic centimeters. The box is 8 centimeters long by 14 centimeters high. What is the box's width? All right, so if we just sketch a little picture of what's going on here. We have a rectangular box. We know the volume is 392. The box is 8 centimeters long. It's 14 centimeters high, and we're trying to find W. All right, so again, volume of a prism, a box is a prism, is the area of the base times the height. No 1/3 this time because this is not a pyramid. So if we were finding the area of just the base, we would be doing 8 times W. So B is going to equal 8 times W. And then if we find the volume, we would say that 392 would have to equal 8 times W times the height of the prism, which would be 14. Okay, so I just replaced V with 392, and then the base with 8W, and then the height with 14. All right, so I can't go ahead and multiply all this together, but I can multiply 8 and 14. So I'm going to go ahead and do that. 14 times 8 is 32. Carry your 3. 8 times 1 is 8, plus 3 is 11. So that gives me 112. So now I have 392 equal to 112 times W. And this is just an equation that I'm going to solve like any other equation. I'm going to cut it in half, and I'm going to use the inverse operation, or the opposite, to solve for the variable. All right, so I'm going to end up dividing by 112. So over here, 112 into 392. It'll go into 392 one time. Oh, sorry, 2 times. Actually, 3 times. All right, so 3 times 112 would be 336. When I subtract, I'm going to have to borrow. So that's going to be 6, and that's going to be 5. I'm going to add my decimal, bring down another 0. So 112 into 560 would be 5 times. And that's going to be 560. All right, so my answer for the width is 3.5. And this time I'm solving for the width, not the volume. So the width is just going to be measured in centimeters, just like the length and the height were. So final answer, 3.5 centimeters. Number 3 says Christy purchases 3 tomato plants in a flower box with a rectangular base. Flower box measures 36 inches long, 12 inches wide, and 5 inches tall. Christy fills the flower box with potting soil so that 1 inch of space remains at the top. How many cubic inches of potting soil are in Christy's aquarium? So again, if we just make a little sketch of what we're talking about, it's another rectangular prism, something like this. We're told that it's 36 inches long, 12 inches wide, and 5 inches tall. All right, so she's filling it up with dirt, and she's leaving 1 inch of space at the top. So we just want to know the number of cubic inches of the soil. All right, so rather than measure the volume of the whole box, we just want the measure of the dirt. So since the dirt is only going to be 4 inches, because she's going to go 1 less than to the top of the box, then we're just going to multiply these numbers together. So we know that the volume of a rectangular box is the area of the base times the height. And you probably learned in elementary school length times width times height. That's still a formula you can use, but we have switched to this one just because it works for any prism, whereas this one just works for rectangles. All right, so the area of this base is this rectangle at the bottom. So I'm going to do 36 times 12, which is just length times width. So this is kind of just another way to write that. So I'm going to do the volume is equal to 36, or I'm going to do the base first. 36 times 12. So 36 times 12 would be 12, 6, 7, start with a 0, so 2, 13, 432. All right, so now if I find the volume, I'm using 432 times the height, which is 4. So 432 times 4 would be 8, 12, 16, 17. My volume is 1,728, and this is in inches. So we would say cubic inches for the volume of the dirt. All right, number 4, Gobble One chocolate comes in a package shaped like a triangular prism as shown below. Each triangle face of the prism has a base of 2 inches. So this part has a base of 2 inches and a height of 2.5 inches. What is the volume of the package? So again, we're talking about a prism. Prisms use the formula, the area of the base times the height. In this case, my base is a triangle. Because I call this a triangular prism, that names the base as a triangle. So I know to find the area of a triangle, I use 1/2 base times height. So this time I'm going to do 1/2 to solve for the area of the base. 1/2 times 2 times 2.5. All right, so if I do 2.5 times 2, that's going to give me 5.0, just 5. And then I have to do 1/2 of 5. So if I divide 5 by 2, 2 will go into 5 twice. When I subtract, I get 1. Bring down my 0, bring up my decimal, 2 will go into 10 5 times. All right, so I'm back to the area of the base being 2.5. All right, since I'm finding the volume, I need to now multiply that times the height. So the volume is going to be 2.5 times the height, which in this case, the height is, this box has been flipped over, so the height is actually, the length is 10. So if I multiply 2.5 times 10, it's going to give me 0, start with a 0, 5, and 2, add those up. It's 1 decimal place, so 1 here. My volume is 25, and this again is being measured in inches, so this would be cubic inches for volume, 25 cubic inches. All right, keep going. Number 5 says the Science Museum has a terrarium, the shape of a triangular pyramid. The dimension of the terrarium are shown below. What is the volume of the terrarium? All right, so we're back to a pyramid. So we know that that formula is slightly different. It's 1/3 the area of the base times the height. So I'm going to start again by finding the area of the base. In this case, the base is this triangle right here, the bottom. All right, I know that a triangle, the area formula is 1/2 the base times the height, little b, times h. So if I'm looking at the triangle at the bottom of my pyramid, I'm going to do 1/2. The base here is 6, and the height of the base, the triangle, the flat part on the bottom, is 8. So I start by multiplying 6 times 8, that's 48. So then I'm going to have 1/2 of 48. If I divide 48 by 2, I'm going to get 24. So that's my base. And then to find the volume, I still need to do 1/3 of 24. And then the height of the actual triangle is this part right here. That would be 12. Okay, so to finish this up, I'm going to do 24 times 12. That would be 48, and then a 0. 1 times 4 is 4. 2 times 1 is 2. Add these up. 288. That's this part. I still need to divide it by 3. So dividing into 288. 3 will go into 28 9 times. That would be 27. Subtract, I get 1. Bring down my 8. 3 will go into 18 6 times. So my answer for volume would be 96, and this is being measured in feet, so this would be in cubic feet. All right, so again, volume, it's always kind of the same. Pyramids are going to be 1/3 the area of the base times the height, and then prisms are always going to be the area of the base times the height. So in all your volume problems, you're typically starting by finding this area of the base first. Know that the area of the base, if you're questioning what the base is, just think about what you would call it. If I call this a triangular pyramid, then I know my base is a triangle. If I call this a square pyramid, then I know my base is a square. Same thing with the prisms. All right, number 6, find the total and lateral surface areas of the figure. All right, so for surface area, I'm finding the area of each side. So I'm just going to try to keep this organized to make sure that I find each side. I would call this a triangular pyramid, so that tells me my bases are the triangles. So I'm going to start by finding the area of the base. I know the formula for a triangle's area is 1/2 the base times the height. So then I want to do 1/2. And the base and the height of a triangle are the lines that form a right angle. So I can see at the bottom that this side and this side are forming the right angle. So for the area of this triangle, I'm going to use 6 times 6. So that would be 36. And then I still need to do 1/2 of 36, and that would be 18. Okay, then I need to find the area. So I started by finding the area of the triangle. And now I'm going to find the area of each side. So I'm just going to have a first, second, and third side. They're all rectangles. So they're all going to be found using base times height. So I just want to make sure I get all 3 of them. So I'm going to start by finding this one here first. All right, so that's 6, this length right here. And then the height of the prism is 12. So that would be 6 times 12. And you can do these in any order. It doesn't really matter. 6 times 12 is 72. Right, and so then if I take this next rectangle right here, this is length is 6, and this length here is also 12. It's the same. So 6 times 12 again would be 72. And then the last triangle is this one on the front right here. So I can see that the height of the triangle again is 12, and then the width right here is 8. So I would do 8 times 12. And that would be 96. So that's my third rectangle. And I want to find lateral and total. So I'm going to start by finding the area of just the sides, just the rectangles. Lateral is the surface area, the area of the sides without the bases. So I'm going to start by adding those together. So 72 plus 72 plus 96. 6 plus 2 is 8, plus 2 is 10. Carry your 1. 1 plus 9 is 10, plus 7 is 17, plus 7 is 24. So my lateral surface area would be 240, and this is being measured in inches. And because it's area, then it's going to be measured in square inches. All right, for the total surface area, I'm just going to take that same number, the lateral, the sides, and just add the bases now to that. Now, there were 2 triangles, so I need to make sure I add both of my bases to this number right here. So since I have 2 triangles, 18 plus 18, really the total of the bases is 36. All right, so when I add 240 plus 36, that gives me 276. So my total surface area is 276. Again, this is being measured in square inches. The total is 276. All right, number 7 says Samantha deconstructs a box to put in the recycling bin. When the box is flattened, it has the shape shown below. Which expression can be used to determine the total surface area of the box? So before I look at my answer choices, I'm just going to look at my net over here. I can see that this would be a rectangular prism because all the sides are rectangles. I know in a rectangular prism that opposite sides are the same. So I know I'm going to have 2 equal rectangles for each of these. So I can tell that this rectangle is the same as this one. These 2 are the same, and these skinny ones are the same. So if I just find the area of one of those and multiply by 2, then that gives me the area of those 2 combined. All right, so if I look at just this top rectangle, I can see that the width here is 2, and I just need to know the length right here because I know a rectangle is length times width or base times height. And I can tell for all of these triangles, this length here is going to be 5. So this top part right here is going to be 2 times 5. And I know that there are 2 of those, right, this one and this one, so I need to multiply that by 2 as well. All right, so that gives me the area of one of my triangles. All right, and then I'm going to find the area of the skinny one now. So I have same length here, 5, and then I know that the width of here is 1. So if it's 1 here, it's still going to be 1 here. So this would be 5 times 1, or 1 times 5. It doesn't matter how you do it. And I can see that there are 2 of those also. So I'm going to multiply it by 2. And then if I want just this little rectangle on the side, I would multiply 2 times 1. And again, I know there's 2 of those, so I'm going to multiply that by 2. All right, and then surface area, or total surface area, and I am finding the total, is just adding all those up. So I want to see which of these answer choices matches what I have here. So this is 2 times 2 times 5, that's what I need. 2 times 1 times 5, that's also what I need. 2 times 1 times 2, that's the same thing, it's just in a different order. So it looks to me like A is going to be our choice. But let's go ahead and like this one. It's not 2 times 2 times 2 is nothing that I have here, so I know it's not that one. 2 times 1 times 2, that is the same as this. Again, 2 times 2 times 2 is not one that I use, so I'm going to reject that. And then 2 times 2 times 5 is what I'm using here. 2 times 1 times 5, but they left off this part right here. So D is not my answer either. So I'm going to go with A as the expression that can be used to determine the total surface area. On 8, it says the net for table decoration is shown below. When folded, the figure forms a rectangular pyramid. If the rectangular base measures 4 by 3 inches, what is the surface area of the table decoration? Round to the nearest tenth if necessary. All right, so I can tell if I'm finding surface area, I need to find the area of each part of the net. I'm going to start with the base. It tells me that the rectangular base is 4 by 3. So it looks like this would be the 4 and this would be the 3 just because it looks longer to me. So I'm going to start by finding my area of the base. I know rectangles again are base times height or length times width. That was going to be 4 times 3, which is 12. I know the opposite triangles are going to have the same area, so I'm going to start with these two right here. So I'm just, let's see, so I'm just going to say, I don't know, the front and back triangles, I guess, just to distinguish between the two, would be 1/2 of the base, so that would be 4, times the height, which would be 4.5. Okay, so if I do 4.5 times 4, gives me 20, carry your 2, 4 times 4 is 16, plus 2 is 18, there's 1 decimal, so 18.0. And then I need to do half of that, right? So half of 18 would be 9. But there's a front and a back, so I'm going to add 2 of these together to get a total of 18 for the 2 triangles. All right, if I do the side triangles, okay, again, I'm doing 1/2 of the base. So this time the base is 3, and the height is 4.7. So if I do 4.7 times 3, it's 21. 4 times 3 is 12, plus 2 is 14, and there's 1 decimal. All right, and then I need to divide it by 2 for the 1/2. So if I divide by 2, 2 will go into 14 7 times. Bring up my decimal, bring down my 1. It'll go into 1 0 times, and then I'm going to add a 0, so 2 will go into 10 5 times. All right, so for one triangle, it's 7.05, but for 2 triangles, I'm going to double that, and so that would give me 14.1 or 14.10. I want to go ahead and find the surface area, total surface area, so I need to add all 3 of these numbers together. So I've got my base, my 2 triangles here, 9 and 9, and I've got my 2 triangles here, 7.05 and 7.05. All right, so 12 plus 18 plus 14.1, and remember, if I have a decimal, I need to line that up, so I'm going to give these all 0.0. And then when I add them, that gives me 1. 2 plus 8 is 10, plus 4 is 14, and that would be 4, and I'm going to bring down my decimal. So my total surface area is 44.1, and its area, so that means I'm being measured in square inches, not cubic inches. And it says to round to the nearest tenth if necessary. So since I only go to the 10th place, I don't need to round anything. I'm just going to leave it. It's 44.1. All right, I keep on going. Number 9 says Frank bought some cereal. It came in a box that is 12 inches long, 2 inches wide, and 18 inches tall. What is the surface area of the box? So I'm going to start by just sketching. This just helps me visualize what I'm finding the area of. Okay, so I know in a rectangular prism, there are 6 rectangles that I need to find the area of. So you can keep track of them however you want to. I'm going to start with just the front and the back. I'm just going to use F and B for that. I guess I should put some dimensions. So this is 12 and 2 and 18. All right, so front and back. So the front triangle and the back triangle are going to be 12 times this height right here, which would be 18. Okay, so 12 times 18, 16, 9, start with a 0, 2 and 1. So 6, 11, 216. And I know that there are 2 of those, so 216 plus 216 would be 432. And then I want to do the maybe the side, the left and right triangles. So that would be this length here, which I'm calling 18, and the width here, which would be 2. Obviously, my rectangle is not drawn to scale, but that's okay. 18 times 2 is 36, and again, these sides are the same, so I'm going to double that. 36 plus 36 is 72. And the last rectangles I need to find are the top and the bottom triangles. So the top rectangle, not triangles, top rectangle would be 12, this distance here, times the length here, so that would be 12 times 2, right, which is 24. Again, top and bottom are the same, so 24 plus 24 would be 48. I'm looking for the surface area, so that means the total. So I'm going to add up all of my rectangles. 2 plus 2 is 4, plus 8 is 12. 1 plus 3 is 4, plus 7 is 11, plus 5 is 15, and then 1 plus 4 is 5. That gives me a total surface area of 552. This is in inches, so that's going to be in square inches, total surface area. Okay, so again, front and back, left and right sides, top and bottom, were what I'm using for the surface area. All right, number 10 says, look at the figure on the right. Which of the following has a volume that is 1/3 the volume of the figure shown? So this is a prism. So if I were finding the volume of this prism here, I would do the area of the base, so 3 times 3.5, this area right here, times the height of the prism, which would be 2.5. Okay, so I would do something like this. If it were a pyramid with the same base, okay, then I would do 1/3 of the area of the base times the height. Okay, so really, though, all I'm doing is trying to pick the rectangle then that has the same height and the same base as the prism that I see. All right, so the base of this rectangle is 3 by 3.5. So if I just quickly kind of look at my choices here, I have 9 and 7.5, 9 and 7.5, 3 and 2.5, and 4 and 3.5. Okay, so none of these have the same dimensions as the area of the base right here. All right, so what may have happened is that they turned the rectangular prism. So now I'm going to go back and look and see if any of my rectangles have the same dimensions as one of these sides. All right, so 9 and 7.5, none of those fit the dimensions here. So I know it's not A, because this can't be the base of this, no matter on which way it's being set. Okay, so if I look at the next one, the base of this pyramid is 9 and 7.5. Again, these don't match the dimensions here, so this can't be the case. And then here, if I look, I have 3 and 2.5. So 3 and 2.5, if I took this box and I set it up right like this, then the base would now be 3 and 2.5. So that would work as long as the height is 3.5. And I can see here that it's pointing to a height of 3.5. It looks to me like B is going to be my answer, but I'm going to go ahead and look at D. So D is 4 and 3.5. It has a base of 4 and 3.5. So again, those don't match these dimensions here. I have 3.5, but not the 4, so it can't be D. So it must be B. And again, I just kind of review why that's the case. So that volume is the length times the width times the height, or the area of a base times the height. A pyramid is found exactly the same way, only you divide it by 3, or you take 1/3 of it. Right? So what I need is the same dimensions of the box, just in the shape of a triangle. Okay, so same height, same dimensions of the base, okay, just a pyramid instead of a prism. All right, so again, that's what I'm looking for. This is what this one has. It has the 3, right? It has the 3. It has the 2.5, and it has the height of 3.5. So they've just taken this box and set it on its side, right? So it's the same box, it's just sitting a little differently this time. All right, okay. Number 11 says if the width and length of a rectangular prism are tripled, how does the volume of the prism change? Okay, so again, when I'm not sure, I just always draw a picture. And it's obviously not a good picture, but it works. All right, so if I'm not sure how to answer this question, then I could go ahead and just make up some dimensions and see what happens when I triple it. All right, so let's say the width and the length of a rectangular prism are tripled. All right, so let's say I have a box that's 2 by 3 by 4. If I triple those, that means I'm going to multiply each of those by 3. All right, so the width and the length. So 2 times 3 would be 6, and 3 times 3 would be 9. It doesn't say anything about the height, so the height would stay 4. All right, so I'm talking about the difference in their volumes. So the volume here would be the area of the base, so that would be 2 times 3 times the height, which would be 4. So if I'm finding the volume of this one, the area of the base, okay, it would be 6 times 9, so 6 times 9 times the height, which would be 4. All right, so 2 times 3 is 6, and 6 times 4 is 24. So that gives me a volume of 24, whatever the units are, and then cubic units. And then here, 6 times 9 is 54, and then if I multiply by 4, that's 16, 216. So the volume here is 216. Okay, that's quite a bit more. Now you might guess that because it's tripled, you might think, oh, well, the volume will just be tripled. But actually, if we look at 24 times 3, we would get 72. So it was more than tripled. So why is that? All right, so if we go back to what we had originally, we had 2, and we tripled it. So basically, that 6, we multiplied by 3. And that 3, we tripled it, this 3 right here, to make it a 9. So we had 3 times 3. And then the 4, we just left alone, so it was 4. Okay, so if we kind of rearrange this, what did we do? We multiplied by 3, not once, but twice in the volume. Okay, so basically what happens is the volume doesn't just triple, it triples twice, or it increases by a multiple of 9, actually, not just a multiple of 3. All right, so how does the volume of the prism change? Okay, it is multiplied by 3 times 3, or by 9. Okay, so this was multiplied by 3, and this was multiplied by 3, so together, right, that's multiplied by 9. All right, last page, it says, Coach Edmondson marks the soccer field each week with striping paint using a roller wheel, such as the one shown below. If the radius of the wheel is 4 inches, what is the distance the wheel travels in feet in one full rotation? Use pi equals 3.14, round to the nearest tenth. All right, so if he is rolling, if he's striping the field, then this roller is moving, right? A rotation, one rotation, it says. So that would be the distance around here, which we know as the circumference. All right, and when we studied circumference, we used the formula pi times the diameter. Okay, so I've been given the radius. The diameter would be twice that, so it would actually be 8 in this case. Pi, they tell me to use 3.14. Diameter is double the radius, so in this case 8. So if I multiply 3.14 times 8, I get 2, 3. That would be 8 times 1 is 8, plus 3 is 11. 8 times 3 is 24, plus 1 is 25, and then I'm going to move my decimal. So 25.12. So the circumference, or one rotation around this, would be 25.12. Okay, if I do multiple rotations, I would just keep multiplying my circumference. But it just says one rotation, one full rotation. The trick on this one is that they gave me the radius in inches, but they want to know the distance the wheel travels in feet. All right. What I have to do is take, this is in inches, and divide it by what? 12, because 12 inches are in a foot. So I'm going to divide 12 to 25.12. So 12 going into 25 twice, that's 24. When I subtract, I get 1. Bring up your decimal, bring down your 1. 12 won't go into 11, so 0 times, and I'm going to bring down my 2. 12 will go into 112. What is that, 9 times? Yeah, 9 times 12 is 108. Then I subtract, I'm going to get 4, bring down another 0. 12 will go into 40. Let's say 6 times. Oh, not 6 times, 3 times. 3 would be 36. And then I can see that that's just going to keep repeating, so 2.093 repeating in feet when I change it to feet. All right, and then the last thing I want to pay attention to is it wants me to round to the nearest tenth. So 0 is in the 10th place. So I'm going to look at the 9 to determine, okay, if that's going to round up. Since 9 is 5 or greater, that rounds the 0 up to 1, and then everything else just goes away or becomes a 0. So this is 2.1 feet, round it. So 1 full rotation would be 2.1 feet. All right, last question says to find the area of the roller wheel above, so this one here, in square inches. So if I go back to my area formulas for a circle, area formula is pi times the radius squared. So I go back to my radius this time, and pi is still 3.14, the radius is 4, so I need to square that. I'm going to do my exponent first. So 4 squared means 4 times 4, which is 16. All right, so then I need to multiply 3.14 times 16. So if I do that, 4 times 6 is 24, carry your 2, 6 times 1 is 6, plus 2 is 8, 3 times 6 is 18. Start with a 0, 1 times 4 is 4, 1 times 1 is 1, 1 times 3 is 3. This is 4, 12, 10, and 5. There's 1, 2 decimal, so 50.24. Okay, and this is being measured in 4 is in inches, so inches, and this would be square inches because it's area. And this one, I'm leaving it in square inches, so I'm good there. It's not asking me to round, so I'm good there. So this would be my final answer. The area is 50.24 square inches. All right, so that's the end of the Unit 8 test review, Part 2 test review. Good luck on your tests.